Hello everyone. So in the previous two videos or three videos, we discussed the basics of the time and work. When two or more than two people will work, maybe they'll work together or they'll start together. After a few days, some people will join. Then how many days are required to finish the work? In this concept, we'll see that what happens if people will not work together. They'll work in a pattern. Maybe if there are two people, they'll work on the alternate days, and if there are more than two people, they'll work in rotations. Fine. Let's see. Let's look at the question here. A and B can do a piece of work in 10 and 15 days, respectively. Starting with A, they start working on alternate days. In how many days will the work gets finished? Now, what's given here? Who's going to start the work? A. So it's very important that the question tells you that who's going to start the work. Because maybe in some questions, the answers will be different. If you start with A or you start with B, in both the cases, the answers will be different. Now, let's try to understand the logic here. It's better to use the second method in these type of questions. Let's see what happens here. 10 and 30 days. A can do a piece of work in 10 days, while B can do the piece of work in 30 days. And if you look at the previous question, what was the data? 10 and 15. So let's try to solve it for this data first. A can do the whole work in 10 days, while B can do that work in 15 days. So let's assume that the total work is LCM of 10 and 15. That comes out to be how much? 30 units. Now A can do these 30 units in 10 days. So what is A's 1 day's work? I'll say 30 by 10. That is equal to 3 units. What's the work done by B in 1 day? So 30 by 15. That is equal to 2 units. Fine. How they are going to start the work? A will start the work. That means on very first day, he'll do 3 units. Second day, it's a turn of B. So B will do 2 units. So this is 2 days work. So can I say in every 2 days, the work done by both of them will be how much? 3 plus 2 and 3 plus 2 and so on. What's the total work here? 30. This 3 plus 2 will give you 5. So how many times I should add this 5 so that the sum becomes 30? I can see it here. 1, 2, 3, 4, 5. So this 2 days work is just one cycle for me. That means in one cycle, both of them will be working for 1 day each. Fine. So how many cycles I need to add? 1, 2, 3, 4, and 5. 5 cycles are required. So in 5 cycles, they'll be able to finish what? The total work here. And who has started the work? A has started the work. So one cycle is of 2 days. So 5 cycles will be equal to what? 5 into 2, 10 days. So how many days are required to finish the whole work? I can say 10 days here. This is clear or not? This 5 should be added how many times? 6 times. I made a mistake. This 5 will be added 6 times. That means 6 cycles are required. 6 cycle, and each cycle is of 2 days. So total number of days will become 12 days here. Yes or no? What if B starts the work? Let's see the difference here. If B starts the work, then the work done in the first day will be 2. Work done on the second day will be 3. So effectively, work done per cycle will be again 5 here. That means there won't be any difference here. Fine. So what is next 2 days work? Again 5. Next 2 days work, again 5. So this 5 should be added how many times here? Again you'll say 6 times. That means you'll have to count 6 cycles here. Since each cycle is of 2 days, 6 cycles will be of 6 into 2, 12 days. Say it does not matter that who's going to start the work in this particular question. Fine, because I am getting the answer of complete cycles. Exactly 6 complete cycles are required. Let's see what happens if the number of cycles are not complete in the next question. Now, what's the data given here? A and B can do a piece of work in 10 and 30. So again, the total work here will become LCM of 10 and 30, which must be equal to 30 units. What is A's 1 day's work? Let's say 30 by 10, that is 3. And B's 1 day's work will be 1 unit. Who is going to start the work again here? A. So on first day, A will do 3 units. Second day, B will do 1 unit. Third day, again A will do 3 units. Fourth day, B will do 1 unit. So I can see that in every 2 days, the work done by them will be equal to how much? 3 plus 1, 4. The next 2 days, again the work done would be 3 plus 1, 4. Each cycle will be of 2 days. Fine. Again on fifth and sixth days, the work done by them will be how much? 4 units. Now what do you want? The total work has to be 30. So this 4 should be counted how many times so that the sum becomes 30. I can say that maximum I can count this for how many times? 7 times. So we'll have 7 complete cycles here. And each cycle, the work done is how many units? 4 units. So number of days in 7 complete cycles will be 14 days. And I can say that in these 14 days, they must have finished how much work? 4 into 7. That is 28 units. So work done in 7 complete cycles, that means in 14 days, is 28 units. And what was the total work? It was 30. So how many units of the work is still left? I can say 2 units. And the next day would be 15th day. Now, if you look at the pattern here, A will be working on the odd number of day. That means day number 1, day number 3, day number 5, and so on. So on 15th day, it's A's turn. A's turn. And how much work is left? Only 2 units is left. So A needs how much time to finish these 2 units? I know that A can do 3 units per day, and the work left is only two. That means A does not need a complete day here. He needs how much time? Work left is 2 units, and he can do 3 units per day. So he needs two-thirds of a day to finish the whole work. So let's count the total number of days here. This much works, 28 units, was finished in 7 complete cycles. And one cycle is of 2 days. So 7 cycles will give you 14 days. Yes or no? And we have incomplete 8 cycle here. So the total number of days will become 14, which was equal to 7 cycles. And on 15th day, A will finish the work. He'll not work for the complete 1 day. He'll work for only two-thirds of a day. So the answer becomes 14, 2 by 3, I believe. Yes or no? Now, we are getting a fractional day here. That means B did not get the next day. B did not get the extra term. A got the extra turn here. Fine. Let's look at one more case here. What if B starts the whole work? Everything remains same. What I can say, B will do how many units per day? 1. Then A will do 3 units again. So in 2 days work, again, the total work done will be how much? 4 units. In next 2 days, again the total work would be 4 units. And what was the total work here? We have already seen that the total work was 30 units. Now this 4 should be counted how many times so that it becomes 30. But 30 is not a multiple of 4. So I can count this 4 maximum how many times? 7 times, like in the previous question. So how many maximum complete cycles can be considered here? I can say again 7. So number of days in 7 complete cycles will be 14. Yes or no? And in 14 days, they must have finished how much work? Again 28. How much work is left now? 2 units is left. And the next day would be the 15th day. Whose turn is now? I can say B. And how much work is left? It's 2 units. I know that nobody can work for more than 1 day continuously. Now I can see that the work left is 2 units and B can do only 1 unit per day. That means he won't be able to finish the remaining work in the next day. He'll come on the 15th day and he'll do 1 unit. Yes or no? So 28 plus 1, 29 units will be finished in how many days? 15 days. Still one more day unit is left. Whose turn is now? On 16th day, it will be the turn of A. It will be the turn of A. Now, what's the efficiency of A? A can do 3 units per day, and the work left is only one unit. So the time required, days, is equal to work left by the efficiency of A. That is 1 by 3. So now the answer becomes 15 1 by 3. Yes or no? I can see the difference here. If A starts the work, what was the answer? It was 14 2 by 3. And if B starts the work, the time required is 15 1 by 3. Obviously, in the second case, the number of days will be more than in the first case. What's the reason behind it? If you look at the efficiency of A and B, A is more efficient than B. So if A starts the work will get finished in 14 2 by 3 days. But if B starts the work will be finished in 15 1 by 3 days. So if a more efficient person starts the work, then the number of days will be what? Less than the previous case. So if it's not given in the question that who's going to start the work, but if he says that find the least number of days, in that case, the work will be started by the person who is more efficient. Let's look at one more case here. This is what I was talking about. A and B can do a piece of work in 10 and 40 days respectively. If they work on the alternate days and find the least number of days, look at this least number of days in which the work will be completed. It's not mentioned that who's going to start the work, but you want to minimize the number of days. You want to minimize the number of days. That's why you'll start by the person who is more efficient. Yes or no? So what's given here? 10 and 40. LCM of 10 and 40 will give you 40 units. So the total work here is 40. A is going to start the work because you want to finish the work in minimum number of days. So A's 1 day's work will become 40 by 10. That is equal to 4. And B's 1 day's work will become 40 by 40. That is equal to 1. How they'll work? They'll work on alternate days. So on first day, A will do 4 units. Next day, B will do 1 unit. So in one cycle, they can finish 5 units. This is clear or no? And what's the total work here? 40 units. This 5 units should be counted how many times? So that it becomes 40. I can say 5 into 8. We'll make it what? 40? Yes or no? So how many cycles will be counted? 8 complete cycles will be counted. And each cycle is of 2 days. So 8 cycles will be of 16 days. So in how many days the work will be completed? I can say 16 days. Let's look at one more case. A and B can do a piece of work in 10 and 100 days. So what's the total work? Let's take it equal to 100. So what is A's efficiency? 100 by 10. That is 10 units per day. What is B's efficiency? 100 by 100. That is 1 unit per day. If they work on the alternate days and find again he's saying least number of days. So how they'll start? A will work on the first day, then B will work on the second day, again A will work on the third day, and so on. So first day's work would be 10, second day's work would be 1. Then again you'll have 10, again you'll have 1. So can I say in every 2 days the work done will be equal to 11? Yes or no? In every 2 days the work done will become 11. And what's the total work? 100. So in how many times 11 should be counted so that it becomes 100? Since 100 is not a multiple of 11, I cannot count 11 more than 9 times here. My value should be closer to what 100? This 11 should be counted 9 times. When you count this 11 9 times, you get 99 units. Now, what was 11 here? It was one cycle's work. And I've counted it how many times? 9 times. So, one cycle is equal to 2 days. So, 9 cycles will be of 18 days. So, can I say by the end of 18 days, they must have finished how many units? 99 units. How much work is left? Out of 100, they've already finished 99. 1 unit of the work is still left. Whose turn is now? I can see that A will be working on the odd number of days. The next turn would be the 19th day. That means A will come and finish the remaining work. What is A's efficiency? It's 10. So days required to finish this one unit at the rate of 10 units per day will be only 1/10. So let's try to count the total number of days here. These 9 cycles will give you 18 days, and this would be the 19th day. So total number of days will be 18, 1 by 10. Only two people were working. Let's look at the case when the number of people are three here. This one. A, B, and C can do a piece of work in 10, 20, and 40. So step number one is what? Assume some work here. LCM of 10, 20, and 40 will be 40 units. A can finish the 40 units of work in 10 days. So what is A's 1 day's work? It's 4. B's 1 day's work will be 2. And C's 1 day's work will be only 1. If they work in rotation starting with A, that means on the first day, A will finish 4 units. Second day, B will do 2 units. Third day, C will do 1. So effectively, they must have finished 7 units in one cycle. And remember that here this one cycle is equal to 3 days. Each cycle will be of 3 days. And in one cycle, they're able to finish 7 units. Can I say in every 3 days, they'll be doing these 7 units? The 7 should be counted how many times so that it becomes 40? But 40 is not a multiple of 7. That's why maximum the 7 can be counted how many times? 5 times. So the 7 units work when counted 5 times will make it 35 units. And कितने दिन निकल चुके हैं already? One cycle is of 3 days and I'm going to count 5 such cycles. That means in 15 days, they've already finished how many units? 35. On 16th day, whose turn is now? 16th day, A will come and he'll do how many units? 4. So this 4 should be added in 35. That makes 39. So by the end of 16th day, I can say that they must have finished 39 units. Still one more unit to go. And on 17th day, whose turn is now? It's the turn of B. B can do 2 units per day, but he needs to do only remaining 1 unit. That means he'll take half a day. So what's the total number of days? I can say that 15, 16, and this is half more. So answer becomes 16 and a half. Remember that if there are 3 people, in that case, one cycle would be of 3 days. If there are 4 people, then the one cycle will be of 4 days.